GUID partition table is a standard for the layout of the partition table on a physical hard disk, using globally unique identifiers. Although it forms a part of the Unified Extensible Firmware Interface standard, it is also used on some BIOS systems because of the limitations of master boot record partition tables, which use 32 bits for storing logical block addresses and size information. As of 2010, most current operating systems support GPT. Some, including OS X and Microsoft Windows, only support booting from GPT partitions on systems with EFI firmware, but FreeBSD and most Linux distributions can boot from GPT partitions on systems with either legacy BIOS firmware interface or EFI. History. The widespread MBR partitioning scheme, dating from the early 1980s, imposed limitations which affect the use of modern hardware. One of the main limitations is the usage of 32 bits for storing logical block addresses and size information. For hard disks with 512 byte sectors, the MBR partition table entries allow up to a maximum of 2 TB. Intel therefore developed a new partition table format in the late 1990s as part of what eventually became UEFI. The GPT as of 2010 forms a subset of the UEFI specification. GPT allocates 64 bits for logical block addresses and therefore allows a maximum partition size of 264 or sectors. For disks with 512 byte sectors, that would be 9.4 ZB or 8 ZI bar 512 byte sectors 512 bytes per sector. Features: MBR-based partition table schemes insert the partitioning information for 4 primary partitions in the master boot record. In a GPT, the first sector of the disk is reserved for a protective MBR such that booting a BIOS-based computer from a GPT disk is supported, but the bootloader and OS must both be GPT-aware. Regardless of the sector size, the GPT header begins on the second logical block of the device. Like modern MBRs, GPTs use logical block addressing in place of the historical cylinder head sector addressing. The protective MBR is contained in LBA0, the GPT header is in LBA1, and the GPT header has a pointer to the partition table, or partition entry array, typically LBA2. The UEFI specification stipulates that a minimum of 16,384 bytes, regardless of sector size, be allocated for the partition entry array. On a disk having 512 byte sectors, a partition entry array size of 16,384 bytes and the minimum size of 128 bytes for each partition entry, LBA34 is the first usable sector on the disk. Hard disk manufacturers are transitioning to 4,096 byte sectors. As of 2010, the first such drives continue to present 512-byte physical sectors to the OS, so degraded performance can result when the drive's internal 4KIB sector boundaries do not coincide with the 4KIB logical blocks, clusters and virtual memory pages common in many operating systems and file systems. This is a particular problem on writes when the drive is forced to perform do read modify write operations to satisfy a single misaligned 4KIB write operation. Such a misalignment occurs by default if the first partition is placed immediately after the GPT, as the next block is LBA34, whereas the next 4KIB boundary begins with LBA40. For backward compatibility with most operating systems before Windows Vista, including DOS, OS/2 and Windows, MBR partitions must always start on track boundaries according to the traditional CHS addressing scheme and end on a cylinder boundary. This even holds true for partitions with emulated CHS geometries or partitions accessed only via LBA. Extended partitions always start on cylinder boundaries as well. This typically causes the first primary partition to start at LBA63 on disks accessed via LBA, leaving a gap of 62 sectors with MBR-based disks, sometimes called MBR gap, boot track, or embedding area. That otherwise unused disk space is commonly used by bootloaders such as Grub for storing their second stages. On older computers using alternative LBA CHS translation schemes or different extended CHS mappings, with smaller LBA access disks, or on disks accessed via CHS only, The gap could be smaller, although not normally less than lba16 on normal hard disks. Since Windows Vista, the first partition usually starts after a gap of 2047 sectors at lba 2048 as part of its new 1MB partition alignment policy, so no large sector misalignment occurs by default, but serious compatibility problems with older operating systems and disk tools exist. Drives which boot Intel-based Macs are typically formatted with a GPT, rather than with the Apple partition map. GPT also provides redundancy, writing the GPT header and partition table both at the beginning and at the end of the disk. If the minimum size of 16,384 bytes is allocated for the partition entry array, and the default size of 128 bytes is used for each partition entry, then the maximum number of partitions is limited to 128. Legacy MBR, traditionally, in IBM PC-compatible systems the first sector of the disk holds the master boot record, containing the drive's partitioning information and the code of the first-stage bootloader for BIOS-based systems. For limited backward compatibility, this sector is still reserved for a MBR in the GPT specification, but it is now used in a way that prevents MBR-based disk utilities from misrecognizing and possibly overwriting GPT disks. This is referred to as a protective MBR. A single partition type of EA, encompassing the entire GPT drive, is indicated and identifies it as GPT. Operating systems and tools which cannot read GPT disks will generally recognize the disk as containing one partition of unknown type and no empty space, and will typically refuse to modify the disk unless the user explicitly requests and confirms the deletion of this partition. This minimizes accidental erasures. Furthermore, GPT-aware OSes may check the protective MBR and if the enclosed partition type is not of type A or if there are multiple partitions defined on the target device, the OS may refuse to manipulate the partition table. While the MBR layout was defined around a sector size of 512 bytes per sector, the actual sector size can be larger on various media such as MO disks or hard disks with advanced format. Extra space in the MBR typically remains unused. If the actual size of the disk exceeds the maximum partition size representable using the legacy 32-bit LBA entries in the MBR partition table, the recorded size of this partition is clipped at the maximum, thereby ignoring the rest of disk. This amounts to a maximum reported size of 2 TB, assuming a disk with 512 bytes per sector. It would result in 16 TB with 4 kilobyte sectors, but since many older operating systems and tools are hardwired for a sector size of 512 bytes or are limited to 32-bit calculations, exceeding the 2 TB limit would cause serious compatibility problems. In operating systems that support GPT-based boot-through BIOS services rather than EFI, the first sector is also still used to store the first stage of the bootloader code, but modified to recognize GPT partitions. The bootloader in the MBR must not assume a fixed sector size of 512 bytes/sector. Apple's Boot Camp software for Intel-based Apple Macs creates a hybrid partition table to allow the booting of Windows. In this system the protective partition is reduced in size to cover from sector 1 to the sector before the first regular partition included in the hybrid MBR. Additional MBR partitions are then defined to correspond to the next 3 GPT partitions. Partition table header. The partition table header defines the usable blocks on the disk. It also defines the number and size of the partition entries that make up the partition table. The EFI stipulates a minimum of 16,384 bytes be reserved for the partition table array, so there are 128 partition entries reserved, each 128 bytes long. The header contains the disk globally unique identifier. It records its own size and location and the size and location of the secondary GPT header and table. Importantly, it also contains a 32 Costa Rican colons checksum for itself and for the partition table, which may be verified by the firmware, bootloader and/or operating system on boot. Because of this, hex editors should not be used to modify the contents of the GPT. Such modification would render the checksum invalid. In this case, The primary GPT may be overwritten with the secondary one by disk recovery software. If both GPTs contain invalid checksums, the disk would be unusable by software that checks the checksum. The values for current and backup LBAs of the primary header should be the second sector of the disk and the last sector of the disk, respectively. The secondary header at the end of the disk identifies its own table of partition entries, which is located directly before that header. This table must be referenced relative to LBA1. Thus, on 4KN disks with 4KB sectors it does not follow the 512 bytes of the MBR physically and thereby becomes part of LBA0 on disks with larger sector sizes. While the described arrangement happens to occur on disks with 512 bytes per sector, there may be gaps of unused space between them on disks with larger sector sizes. In other words, with 512 byte sectors it starts at 512 byte from the beginning of the disk, while with 4KB sectors it starts at 4096th byte. If multi-sector reads are performed, the actual sector size must be included in the calculation when referencing this table. Partition entries: the GPT uses simple and straightforward entries to describe partitions. The first 16 bytes designate the partition type globally unique identifier. For example, the GUID for an EFI system partition is C12A7328F81F11D2BA4B00AOC93EC93B. The second 16 bytes contain a GUID unique to the partition. Then follow the starting and ending 64-bit LBAs, partition attributes and partition names. As is the nature and purpose of GUIDs, no central registry is needed to ensure the uniqueness of the GUID partition type designators. The location of the partition entries array on disk is defined in the GPT header. The GPT header contains a field that specifies the size of a partition table entry. The minimum required is 128 bytes, but implementations must allow for other values. Also, the sector size must not be assumed to be hardwired to 512 bytes per sector in calculations, that is, there can be more than 4 partition entries in a single sector, and it is possible to have a sector hold only a fraction of a partition entry. Except for the first 2 sectors, the GPT specification just describes the size and organization of a data structure, not in how many sectors it is stored on disk. The 64-bit partition table attributes are shared between 48 bits common attributes for all partition types, and 16 bits type-specific attributes. Microsoft defines the type-specific attributes for basic data partition according to this TechNet article as operating system support. Hybrid MBRs are non-standard and can be interpreted in different ways by different OSes. Unless otherwise noted, OSes provide precedence to the GPT data when a hybrid MBR configuration is encountered. The term no native support on this Archon version should be understood this way: not supported as data disk, only known legacy partitions found in protective MBR are accessible via the OS. Detachable disks, only support for MBR partitioning. No access with end-user applications. GPT contain raw data is accessible with third-party administrator tools for low-level disk access. True file system level support in read or read-write form might be subject of software from a third-party vendor. Unix and Unix-like operating systems, Windows, 32-bit versions. Windows does not support EFI on 32-bit platforms, and therefore does not allow booting from GPT partitions. Windows, 64-bit versions, partition type GUIDs, A. The GUIDs in this table are written assuming a little endian byte order. For example, the GUID for an EFI system partition is written as C12A7328F81F11D2BA4B00AOC93EC93B here, which corresponds to the 16-byte sequence 28H73H2 or C1H1FHF8HD2H11 hours bar 4BH0 hour AOHC9H3AC9H3BH only the first 3 blocks are byte swapped. B. The formation of this GUID does not follow the GUID definition. It is formed by using the ASCII codes for the string HA. It don't need EFI. Such formation of GUID value breaks down the guaranteed uniqueness of GUID. CAB previously Linux used the same GUID for the data partitions as Windows. Linux never had a separate unique partition type GUID defined for its data partitions. This created problems when dual booting Linux and Windows in UEFI GPT setup. The new GUID was defined jointly by GPT-FDISK and GNU parted developers. It is identified as typecode 0x8300 in GPT-FDISK. DAB. The GUID for /USR on Solaris is used as a generic GUID for ZFS by Mac OS X. EAB NetBSD and Midnight BSD had used the FreeBSD GUIDs before their unique GUIDs were created. FAB. Some computer manufacturers have their own GUIDs for partitions that are analogous to the EFI system partition, but that hold bootloaders to launch manufacturer-specific recovery tools. G. The CEF file system uses GUIDs to mark the state of preparation a disk is in. See also. Notes. References. External links, Microsoft TechNet, disk sectors on GPT disks, Microsoft TechNet, troubleshooting disks and file systems, Microsoft TechNet, using GPT drives, Microsoft, FAQs on using GPT disks in Windows, Apple Developer Connection, secrets of the GPT, make the most of large drives with GPT and Linux, GPT FDISK, information on hybrid GPT MBR, converting MBR and BSD disk labels to GPT and booting from GPT disks. Convert Windows Vista SP1 Plus or 7x86-64 boot from BIOS MBR mode to UEFI GPT mode without reinstall. Rod Smith, A BIOS to UEFI Transformation, Support for GPT and HDD greater than 2.19 TB in Microsoft Windows XP, setting up a RAID volume in Linux with greater than 2 TB disks.